Now we're going to review the road widening project option in the Workflow Manager to see how that performs versus the option we just used. So we're going to go up to the CSD AI tab and we're going to click on Project Assist. We're going to leave the alignment issues types as they are. The software has predicted what they are based on previous choices, so we're going to click on Confirm. Before we go ahead and start to complete the workflow, because we're going to be making some fairly significant changes to this design later on, and we don't want to have to go through the process of rerunning everything again, we can actually set up the basis of a thread. So we're going to go to Tools, Set Thread Name, and you'll see why a little bit later on. We're going to call this Road Reconstruction. That name is not something you have to put in, but it will help later on when it comes to getting everything to be updated if you make a design change. So previously we used the saw cut alignment on the left and the right, and we also used the alignment for the EB code widening on the left and the right. Now if we check this is a road widening project button, they immediately get hidden from view. They will actually get bundled up by the software and it will immediately work out how those alignments should be used in relation to a road widening project. So the only extra thing you need to be aware of is the thickness value here. That is an additional thickness that is added to the vertical design after it is matched onto the sarball surface, which is what the road widening project will do. So you can have this vertical design matched onto the existing surface plus a value of X, and we're going to leave that as 30 mil. And then we're going to click on Compute. So the PDF report is generated, which we are free to go through and review as we wish. We're going to close that down, and we're going to go and open up the design data form for our new road. So if we review the template that's been applied, that's all okay. There is some now significant differences with respect of the variations that are being applied for this particular option. We'll have a look at the EB codes in a minute. First of all, the saw cut codes are being positioned onto an alignment, which you can see here, but also they're referencing the natural surface plus that thickness value we assigned earlier of 30 mil. That's the case for both the left and the right. Let's have a quick look at a cross section to see how this looks. You'll notice the blue lines are being displayed. This is using the Display Show Other Objects button, and this is purely for context. You can ask the cross-section window to display alignments from the project, which is great because this enables me to now confirm that the codes are positioned onto the alignment as I need them to be. Very useful tool. What we'll also do here is just turn on the showing of the codes rather than the depth, so we can sort of correlate between what's happening in the design data form. So you can see here we'll go for the left side first. The left saw cut is positioned onto the natural surface plus 30 mil, which just happens to be the thickness of our one layer of subgrade. The EB code, which if we just click here, the left EB, is no longer simply being positioned onto an alignment, it is actually being positioned onto the string. So from a horizontal perspective, yes, it's using the alignment, but from a vertical perspective, it's actually using the vertical grading of this particular string, which if you note is an exact projection of the slope from the center line to the saw cut. So in a nutshell, this is how the road widening project works. It calculates the slope from the center line to your saw cut and projects that slope through to give you the design of your EB. Let's have a look at the vertical design of the center line just before we go and have a look at the vertical design of our EB there. So slight difference from what we had on the first time round. We've actually got IPs being matched onto the surface plus 30 mil. Let's go and see how that's been done for us. We'll click on Auto Profile. You can see we've got a reference surface entry which has been created from here. If we click on the pencil icon to edit it and review, you can see that simply between the start and the end, the software is matching the design onto the natural surface. You'll notice that there is no level adjustment. If you've used the software for a while, you may be expecting to see that 30 mil added here. Now, due to the way in which Project Assist is working programmatically, we actually added in as a separate entry. That's done through this option here, Fit Parameters. If we click on the pencil icon, you can see that all that's happening here is that we are adding 30 mil to any other entry that sits above it. So if you have multiple entries through here, anything you add on at the very end with fit parameters will basically get added on with this one entry here. So you can see 30 mil is being added on. So if we wanted to adjust that, we could adjust that value in here. We're going to click on OK and apply an exit, and then we're going to review the string for the EB to see how these elevations have been set up. So we're going to open up the vertical design, or the vertical grading editor, sorry, for the widen string. So the software's gone and created this for us, and as you can see there's quite a bit going on. The first thing you may notice is that we have design constraints being applied. If we go to the design constraints tab at the top and just make the VG a fraction wider, you can see that we've got a single constraint being added in with a couple of slopes, -2 and -5%. In the CSD AI tab at the top here, in settings, now I'm going to click on settings now, under the default values, when you create a road widening project or a similar project which may require constraints, the software will automatically go and apply them, and the -2 and the -5 that you can see here are being applied from these values. So if at any point you decide, well look, I'd like to have default values of a different range, you can go and apply them in here. You can see there's actually different constraints being applied for different types of design. So that's where the constraint is being applied. So if you want to change it, you can always change it. You can type in -4, click on apply, and now we're seeing where -4% is. So that's where the constraint's being added in. If we go back to the home tab, let's have a look at the auto profile entry. So the auto profile entry is using something called reference point. It's using the slope from the center line to the saw cut to determine the elevations. So if we click on the pencil icon to review, this is the entry that is being created. From the design string, recon road, we only have the one design string that we want to reference. From the saw cut code, I would like to use 2 points. Now think about how we have got this design working. We're looking on the left hand side here. So the software is calculating a slope from the center line to the saw cut, projecting that through to give us the elevations that we want. Now again, you can edit this entry as you wish or create new ones. All we're going to do is click on apply and exit. Nothing has changed. We're going to close that down. That is how the EB code is being designed. Now, if you've been using the software for a while, you may decide that you want to use the match section slope to codes. That will essentially do the same thing. What Project Assist is giving you is a string where you have the vertical design under your full control. Using a design variation will do exactly that. It will project the slope through from here to set the EB, but it will do it consistently over every section with no control. Whereas when you've got the vertical grading editor open for your EB, if you want to make the smallest change at any particular part of that design, you have got the capacity to go in and make those changes yourself. One last thing we'll do is just close everything down. We'll go and make a change to the vertical design. Okay, because the knock-on effect is that quite a few things get impacted. So we're going to make a change to the vertical design of the main road. And in fact, we'll open up the cross-section again, just so we've got some context as to what's going on here. We'll go and raise the center of the road up by, let's say, an extra 30 mil. So we're going to add 30 mil to that design. So we've now got our vertical design sitting 60 mil above the natural surface. Now if I go back into auto profile and was to click on apply and exit, what will actually happen is it will reset the design back down to 30 mil above the natural, which I don't want to happen. So all I'm going to do is now go and edit that entry and make that 60 mil, so that if I was to rerun auto profile, I'd always be 60 mil above. And you can see that there's been no significant change. However, the knock-on effect is that now if I close down the vertical design here, is that the saw cut codes are still positioned 30 mil above, as we've asked. However, the EB codes are no longer being a projection of those particular slopes. So what we're going to do is run a thread which will go ahead and update the auto profile entries for both the left and the right in one hit. So we're going to click on the thread pull down, click on thread editor, and this is what was created when we ran the workflow. The software goes ahead and grabs any auto profile entries for any of the associated strings it's created, which is these here, compute vertical geometry, And it also grabs any design data entries that were created for each of those strings, and then what it'll basically do is go and rerun them in order for us. So in this case, it'll rerun the vertical grading or auto profile entry for our center line, which as we know is going to be 60mm above the natural. It'll rerun any design data that happens to be associated to road reconstruction, which are all of these variations in here. So it's just a case of refreshing them and rerunning them. And beyond that, it's then going to check the vertical geometry, which is what we want, or run the auto profile entries for the left and the right-sided strings. So let's click on compute and see what happens. You can see there that the strings have been reassigned the correct elevations based on the slope from the center line to the saw cut. The auto profile entries that were assigned to both of these have been updated, and we've now got our slopes being adjusted. So if at any point we do go in and make design changes, we have this thread to go and update it. If we click close, you can actually see the thread listed at the very top here, road reconstruction. So if at any point we want to quickly run it again, we can click on compute thread, and that will go ahead and update the design. So in summary, the road widening project will position your centerline of your string onto the sampled surface with a thickness value of your choosing. It will assign that thickness value to your saw cut, position those also onto the sampled surface, and then go ahead and create strings left and right, depending on your design, which will be a projection of the slope from the centerline to the saw cut.